Hello, I'm Sarah Jensen, editor of OEM Off Highway, and welcome to Design and Engineering Insights. Today, I'll be speaking with Steve Heckeroth, founder and CEO of Solectrac, about the company's electric tractor technology. Thank you for joining me today, Steve.
Happy to be here.
So maybe just to start the conversation, could you provide a brief overview of Solectrac and how the company went about developing its electric tractor?
Sure. I was brought up in LA where it was very smoggy, and from a young age, I decided that burning fossil fuels was not a good idea. And when I went into college, the very first Earth Day in 1970, I dedicated my life to finding alternatives to burning fossil fuel. So, as an architect, that's my degree. I built passive solar homes and zero energy homes, and then got into transportation with electric vehicles in the early 90s and found that the battery weight was the biggest issue. It's a big problem. I realized that tractors need weight for traction. So they're an ideal electric vehicle because they can use that heavy battery weight to create more traction for the tractor. And also the electric motors have maximum torque all the way through the low operating speeds of tractors. So you don't have to go 80 miles an hour in a tractor. You're going slow, and that's where electric motors really shine. They're like 95% efficient. So only 5% of the energy is lost to heat, whereas in the diesel tractor, 62% is immediately lost as heat. And so you don't get any of that energy actually doing work for you. So there's huge advantages to electric right off the bat. With that in mind, I started building electric tractors in 1992. And in 95, I got a commission from Ford New Holland to build a prototype and took it out there, and they tested it. And it was, they were very surprised. It was one of the people that was retiring that wanted to do something interesting before he retired. So the major tractor manufacturers, most of their business is building diesel engines. So it's very hard for them to make a transition. So that prototype really didn't go anywhere. They they actually gave it back to me. So I got to use it. But and then I had another commission from an Japanese company to build a minesweep unit where we would go through minefields where they were left over from wars on farmland, and to prevent the farmers from getting killed or losing limbs. We had this big rolling cylinder with chains on a boom out front. We drive it over the farmland and explode the landmines way out in front of the tractor. And I actually made the first remote control electric tractor to do that too, so nobody would be in danger. And then the tractors could stay on and do farming. So it was kind of a double win. Unfortunately, in 98, when the project got going, the Japanese economy tanked and their humanitarian work stopped. So that project ended. In 2012, I really started getting serious about going into production. I thought the timing was getting better. More people were believing in science of climate change, and pollution is still a constant problem. And so I started Solectrac LLC, and right away we got a grant from the US India Science and Technology Fund to build 4 prototypes. I used the $500,000 from this grant to build what I call the e-farmer. It's one specifically designed after the tractors that were built in the 50s before the chemicals came into agriculture. and they wanted everything behind the tractor because they didn't want to breathe what they were spraying, the poisons they were spraying and the chemical fertilizers. So the idea of a front hitch or mid hitch was lost after the late 60s and early 70s. There was no tractors built for cultivation because that was not the way that farmers were doing agriculture.
Mm-hmm.
But with the resurgence of interest in organic farming and regenerative farming, there's also interest in going back to the old ways, not using chemicals. So this tractor, the fourth prototype, after going through all these different learning experiences, I had 3 hitches, one in the front for a loader, a low lift loader, or a front implement, one in the middle for a toolbar that you could actually look right down at and do precision cultivation through the field, and then the typical rear hitch with PTO, category 1, for all legacy implements. So it still remains the only tractor of its kind, electric tractor of its kind. There are several companies building diesel ones now that are similar, but with a mid hitch. But that was sort of the start. And then we got a grant from National Science Foundation. That was to build a tractor that people were more used to. The one with 3 hitches looks very alien. It's kind of a roll cage, but we started importing transmissions from India, and built a utility tractor that is very recognizable because the Indian company we're working with took over the Ford tractor factory when they kicked the British out in 1948. So they continued working with Ford, and it's about a 1990s Ford tractor with a very solid transmission. Everybody who's had those old Fords know that they last for 50 or 100 years. So we've got a good base to work from, and we just take the transmission, the front end, and the wheels, and get rid of the diesel engine and the fuel tank and all the emission controls, and put the electric components in it.
Since you kind of touched on it, could you maybe provide an overview of the technology that is utilized to enable electrification of the tractor? And are there maybe any new or unique technologies that were developed or for it?
Yeah, the main, in 2010, I saw that the biggest disadvantage to electric vehicles is range or runtime in tractors. And so I developed exchangeable battery pack that could be exchanged on any of the hitches. The tractors I build have a front hitch and a rear hitch at least, and the eFarmer has the 3 hitches. So there's plenty of places to exchange battery packs using the hitches. Just like you'd exchange an implement, you exchange the battery pack. So it gives you the option of continuous runtime, which is very important. It's in certain seasons to farmers, like harvest and planting season. So that was a major development. And the other thing that just happened is that electric motors can go very slow, and they have maximum torque at 0 RPM. So you can imagine a diesel tractor that doesn't come up to its maximum torque until about 2000 RPM, trying to go very slow in a transplanting situation, for instance. They're constantly they can burn up the clutch. They're not meant to go that slow unless they have a super low reduction gear, which is very inefficient. But electric motors can go so slow you can hardly see the wheels moving. And so it's ideal for transplanting and a lot of slow speed operations that tractors do. We also developed linear actuators to replace the hydraulics. Linear actuators, when I started using them, they were on satellite dishes, and I used them to raise the rear hitch on the lower links so that we could totally eliminate hydraulics from a conventional tractor. And they're about 10 to 20 times more efficient than hydraulics.
Are there any other aspects that are maybe a little bit different of the tractor that are different from a traditional diesel engine powered tractor, or is it mainly
Well,
those components?
of course, the main two of the main things are that it's zero emission, and the workers. When I take it out for harvesting, for instance, it's the first time that the workers have been able to talk to each other, because diesel engines are about 95 decibels, and our tractors was measured by the National Tractor Testing Lab at 65 decibels, which is like normal background speech. So it was just amazing to these people that were having hearing damage, working around tractors. And diesel tractors idle all day long. That's another huge advantage of electric. When you're harvesting, you move forward for 10 seconds, and then you fill the bins for maybe 10 minutes, and then you move forward for 10 seconds again. And you're only using energy during that 10 seconds, where a diesel tractor is just idling the whole time and making noise and causing respiratory problems and hearing loss. So that's another just amazing. People just can't believe, why hasn't this been done before? So it's about time.
Yeah. Yeah. Okay. And so what sorts of applications is the technology, like what types of agricultural applications or maybe sizes of tractors are you integrating this technology into?
Well, my belief is that we have to go back to smaller farms serving their communities, because both the fossil fuel supply chain and the supply chain from these mega farms exporting their crop all over the world is just too energy intensive to maintain. Whereas if you have a small farm serving its local community, the supply chains are very short to non-existent. You have a solar array on your farm that powers your tractor and your homestead, and you grow the food from solar energy. Your neighbors can walk over and get their food boxes, or they can ride their bike, or they can get in an electric car. And if everything's close around the farm, that's the way it used to be for 12,000 years of agriculture. Most people were involved in food production, and the system was sustainable because it was all localized, and we didn't have these huge supply chains. When fossil fuel came in, and there's so much energy intensity in fossil fuel because it is ancient stored solar energy. It took 3 billion years of photosynthesis to create the fossil fuel that we're burning up in 200 years, and reversing the process that made life possible, causing climate change and other things. And with dependence on solar energy, we can localize food distribution again and shorten those supply chains, and make a sustainable future for our kids.
Okay. And so maybe how do you maybe foresee electrification progressing in the coming years in agricultural equipment or any other potential off-highway, similar types of off-highway equipment applications?
Well, it's already starting to happen, but it's probably going to be about 5 years behind road vehicles, just because farmers, the average age of farmers is about 60 years old, and they're a more conservative group, and are used to doing things a certain way. And they all were all brought up in the fossil age when when we were dependent on fossil fuel. If you had fossil fuel, if your nation had access to fossil fuel, you were a rich nation. If you didn't, you were a poor nation. And so everything has been kind of based on fossil fuel. But that is changing pretty radically now with transportation. And I would look at like Tesla as an example. Pretty much unknown company 10 years ago. In 2018, more people started hearing about it. 2019 and 2020, its market cap started surpassing other auto manufacturers. And in 2020, it actually, its market cap is larger than all the rest of the auto industry combined. It is very hard for an existing auto manufacturer or diesel tractor manufacturer to make the transition from a diesel machine or internal combustion machine, because that's where a lot of their money is put. I mean, that would mean like throwing away half of the company and re-educating their whole workforce to build a new technology. Whereas if you do a pure play electric company, then you don't have that baggage and that mindset to deal with. So I think the pure play electric companies are just going to move like Tesla. And I think, companies like Solectrac could become the Tesla of tractors in the future.
Mm-hmm. Great. Well, thank you so much for taking the time to speak with me today and provide some insight into the company and the technology it's been developing.
Thank you for having me.